Hey guys, welcome back. In this video, I want to provide proof for the chain rule of differentiation that I've learned long time ago. And this chain rule of differentiation is very handy while doing differentiation of any functions because the function can be written as composite functions. And composite functions are those functions which we can write one function inside or within another function. If y is the function of u and u is the function of x, that means that this function y is indeed the function of x. Thus we can write y in terms of x as y is the function of x. Okay, and here this is the example of the composite function because this function g of x is the function of y and g of x is the function within the function which is y is f of u. Therefore, by chain rule of differentiation, we have that differentiation of y upon dx is equals to derivative of f of gx times derivative of gx. So this is the chain rule of differentiation. Or if we express in another term that if dy by dx, okay, is the derivative of u and here du over dx is derivative of gx, then we can write derivative of y over dx is derivative of y over du times du upon dx. Okay, and this is another way to express the chain rule of differentiation. Now let us prove this rule by using the limit definition of the derivative or the first principle. Okay, now what we can write is here differentiation of f of g of x can be written as like this: f of g of x plus h minus f of g of x divided by h limit h tends to 0, right? So this is the first principle or the limit definition of the derivative. Now what can we do is we can modify this using some smart trick to apply this limit. Now what will we do is we will multiply and divide this expression with this gx plus h minus g of x divided by gx plus h minus g of x. So you can notice that this side and this side is exactly equal, which means this will cancel to 1, okay? And the actual meaning of the whole equation doesn't change, but we are including this to modify this limit to get the form that we can easily apply the limit. Now applying this, what we will do is we'll switch the place of the limit. So now we can write as f g of x plus h minus f g of x divided by g x plus h minus g of x, okay? And we can say limit h approaches to 0 times, as we can say that the limit of the product can be expressed as the product of the limit, which means we can distribute this limit to each of the components of the product, okay? So we can apply this limit here. Again, limit h approaches to 0, we have g x plus h minus g of x divided by, now this h will be shifted here, okay? Now from this, what we will do is, see here, this h we can manipulate like this: h plus x minus x. What is it? The value is h. Upon modifying this, the real meaning of the equation doesn't change. So we can modify this h by adding h plus x minus x. And I will tell you the reason why I did this. Okay. Now what we can see is, see here, this value is same as gx plus h minus g of x over h limit h approaches to 0. And this itself is the limit definition of the derivative, which indeed is derivative of the function x. Okay. And why I did here is, see here, this x is the input of this function, and this h plus x is the input of this function. So indeed, if we write like this, it doesn't have any change to the meaning, but we can express in terms of this as an input function. Why I wrote this is because this and this are equal, right? And here also it is now noticeable that here gx plus h is itself is the input of this function, right? And g of x is input of this function. Therefore, we can say that this whole thing is derivative of g of x, right? And then this whole is just derivative of x. And now we are done. We have proved that derivative of this function f of g of x is indeed derivative of the function within the function and the derivative of the function which is inside the function. So we have successfully proved this chain rule, which is also equals to dy over dx equals to dy over du times du over dx. Okay, and why I did this is to modify in this expression such that we can derive important conclusion from the limit properties and limit definition of the derivative. Okay.